Okay, 5.5 is called conditional probability. Conditional probability is the probability of an event occurring given that another event has already occurred. And dependent event is an event whose outcomes are affected by each other. So for example, if you're drawing two cards out of a deck without replacing it, your second draw is dependent on your first draw. Okay, example 1, a computer manufacturer knows that in a box of 100 chips, 3 are defective. Jocelyn will draw 2 chips at random from a box of 100. Determine the probability that Jocelyn will draw 2 defective chips. Okay, so on the first draw, she will have a 3 out of 100 chance that she's picked a defective one. And then on the second draw, since that one would already be out of the picture, she would only have 2 chances to get a defective one out of, and now there would only be 99 left to pick from. So that's the probability. Okay, so that's without replacing. Nathan asks Riel to choose a number between 1 and 40 and says one fact about the number. And Riel says that the number he chose is a multiple of 4. Determine the probability that the number is also a multiple of 6. You have to do it by using a Venn diagram and by the formula. Okay, so a Venn diagram. Okay, so all the numbers 1 to 40. So 1, 2, 3, 4 is a multiple of 4. 5, 6, 7, 8, 9, 10, 11, 12 is of both. 13, 14 is neither, right? 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 is both. 25, 26, 27, 28 is a 4. 29 and 30 is a multiple of 6. 31, 32 is a 4. 33, 34, 35, I'm running out of room here. 36 is both. 37, 38, 39, and 40. Okay, so I put all the numbers 1 through 40 in some place. So determine the probability that the number is also a multiple of 6. So he says that he chose a multiple of 4. So in choosing a multiple of 4, he chose a multiple of 4, so there's 10 items. So what's the probability that it's also a multiple of 6? So that would be 3 out of the 10. So out of those 10, 3 of those numbers are also a multiple of 6. Okay, the formula. So the probability of A and B is the probability of A happening times the probability of B given A. So this means the probability of the B event given the A event. So in this case, probability of A is the multiple of 4, and probability of B is your multiple of 6. Okay, so the probability of A, we knew there was 10 out of 40. Okay, so I'm just going to quickly go here. 4, 8, 12, 16, 20, 24, 28, 32, 36, and 40. So the probability of A and B, so we have there's 3 out of 40. So this is what we were solving for, even though we know the answer. So the probability of B given the A would be 3/40 divided by 10/40, which becomes 3/10. Okay, according to a survey, 91% of Canadians own a cell phone. Of these people, 48 have a smartphone. Determine to the nearest percent the probability that any Canadian you meet during the month in which the survey was conducted would have a smartphone. Okay, so the probability of a cell phone equals 91%. And the probability of, or sorry, did I say smartphone? The probability of cell phone is 91%. The probability of a smartphone given that they have a cell phone is 42%. So the probability, determine probability that any Canadian would have a smartphone. So the formula is the probability of the and statement is, so probability of a smartphone and a cell phone is the probability of a cell phone times the probability of a smartphone given they have a cell phone. So we know this and we know this. So if we multiply, it is 0.3822. So there's a 38% chance you would find somebody with a smartphone. Because obviously, right, this is 91% have a cell phone, and then out of those that have a cell phone, 42% of those people with the smartphone, or have a smartphone. So you still might find somebody without even a cell phone, right? Hillary is a coach on the coach of a junior ultimate team. Based on the team's record, it has a 60% chance of winning on calm days, 70% chance of winning on a windy day. Tomorrow there is a 40% chance of high winds, and there are no ties in ultimates. So what's the chance that they will win? Okay, so the probability of winning and it being calm is 60%. The probability that they win and it's windy equals 70%. What's the probability of it to being calm? What's the probability of it being a windy day? Okay, so tomorrow there's a 40% chance of high winds. So that would leave us a 60% chance that it is a calm day. So let's see. So the probability that they win would be the probability they win and calm plus the probability that they win and it would be windy. Okay, so they have a 60% chance of winning when it's calm times a 60% chance of it being calm, plus probability of winning when it's windy is 70%, and the probability of it being windy is 40%. So I'm going to just do this as decimals. So there is a 64% chance of winning.